I'm Emma-Louise Coffey and you're welcome to the Dairy Edge, the Teagasc Dairy podcast. We're bringing you the latest information, insights and opinion to improve dairy farm performance. On this week's episode of the Dairy Edge, with emissions being a hot topic in the news of late, William Burchill has tips on the use of low emission slurry spreading, which is both cost effective and beneficial to the environment. And he first explains the nutrient value of slurry.
So typically, Emma-Louise, what we have found out on farms is that the nutrient content of slurry will be around 6 units of nitrogen per 1,000 gallons, 5 units of P and 32 units of K. I suppose it's important to highlight here that this will be slurry that's typically in a slatted tank or a slatted unit where there's very little water going in. So typically that would be your typical beef or maybe suckler type slurry. Whereas a dairy slurry where there's a lot of water going into it, you could typically have those values. You might be talking about 2.5 to 3 units of P per 1,000 gallons or 15 units of K per 1,000 gallons. And I suppose this is important if you're talking about, especially if you're applying slurry for either first cut or second cut silage. Like the requirements for first cut silage would be about 100 units of K per acre. And if we apply 3,000 gallons of cattle slurry, thick cattle slurry, that's 90 units of K. It's kind of our K requirement covered for silage. But if the slurry is a bit more dilute, we may have to top up with additional K. And that's where sometimes silage yields can suffer because not enough K isn't going on. I suppose just to sum up on the nutrient value of slurry, one thing I always say to farmers, and it's a good way just to remember about slurry, is that I suppose 1,000 gallons of slurry is very similar to a bag of 0730 with a small bit of nitrogen on the front of it. It's just a good way to remember, what you have in your typical slurry.
When you're talking about the dairy slurry having maybe half the P and K content in terms of nutrients, are you talking about a combination of dairy washings and slurry, or what is the dilution effect there?
The main dilution reason why it would be lower is because there would be, like you said, dairy washings going into it, maybe water off the collecting yard going into it. So it's basically, the reason is nothing much to do with the diet of the animal, it's more so to do with the slurry being diluted with water. And
just talk us through then best practice. When, how, where are we spreading our slurry? What is best practice?
So when we talk about the nutrient value of slurry, Emma-Louise, it's interesting to point out that up to 80 to 90% of the nutrient value in our slurry is coming from our P's and K's, and about 10% coming from the nitrogen side of things. So when we want to make the best use of our slurry, we have to make sure that we're doing practices that maximizes the P and K value of the slurry. So the first thing is we would apply your slurry to paddocks that have a high requirement for P and K, such as your first and second cut silage ground. Also as well, you want to aim to apply your slurry to paddocks that are either in maybe index 1 or index 2 for P and K, so they're in low soil indexes. And we can use the P and K in our slurry to build our soil indexes, which is a cheaper kind of and a more effective way to build them up. Another good source to put out slurry or place to put slurry would be on paddocks that have been taken for surplus bales. Just for example, a crop of maybe 3 or 4 bales to the acre of surplus silage can take out 40 units of K. And by applying maybe 1,000, 1,500 gallons of slurry, that can replenish that P and K to those paddocks. Also, I suppose that's where we want to put the timing then becomes important when we want to maximize the nitrogen value in our slurry. So typically what the research has found is that where slurry is applied in the springtime, you will get about 6 units of nitrogen per 1,000 gallons when you're spreading with a splash plate. That 6 actually reduces down to about 3 units when we spread in the summertime. And the reason behind that is that typically in summertime, we're getting more windy, sunny, drying, evaporating conditions, and that, I suppose, it burns off some of the nitrogen in the slurry. So when it comes to timing, target to get slurry out in the spring. And if you, even on a particular day, if you can pick a day that has kind of a calm, cool, cloudy or even misty day, that is the best time to put your slurry out to maximise its nitrogen value.
And then looking at method, this has become a huge topic of conversation in recent years, and particularly, I suppose, in the last 12, 18 months. The splash plate is what would have been commonly used. Why are we moving away from this?
I suppose one of the main things that has happened and come into focus over the last 12 to 18 months, Emma-Louise, is the fact that as a country we have signed up to reduce both greenhouse gas emissions and another thing called ammonia emissions, okay? So agriculture accounts for virtually all ammonia emissions, 98%, and about a third of our greenhouse gas emissions. And using the trailing shoe or a dribble bar has a lot lower emissions compared to using the conventional splash plate. And that's why I suppose these techniques have been promoted a lot more recently. So we have targets to meet. We have to reduce greenhouse gas emissions by 30% by 2030 and ammonia emissions by 5% by 2030. So this is one, moving to trailing shoe or dribble bar is seen as one of the, I suppose, one of the more practical and maybe one of the more easier of the options that are out there to be able to reduce these emissions from agriculture. Another reason why, I suppose, from a farming point of view, why farmers have moved to them voluntarily, is that these techniques are very good at reducing the contamination of the grass with slurry. And also farmers are finding that they are getting a better nitrogen value from their slurry when they use these techniques.
Talk through the contamination. I mean, I think if we picture the splash plate, we can see the image of a covering of slurry, on the grass cover in the paddock. What are we seeing with the other methods?
Typically what you will see with the trailing shoe and dribble bar, what they're designed to do, I suppose first of all for the dribble bar, what the dribble bar will do is it is placing the slurry in lines on the field. So there's about a 6-inch gap between the lines. So that 6 inches of grass is not contaminated with slurry. And the dribble bar will drop the slurry maybe about 4 to 5 inches above the surface of the grass. So as a thin line of slurry when placed on top of the grass. I suppose the key difference between the dribble bar and the trailing shoe is that where the dribble bar drops the slurry on top of the grass, the trailing shoe has a shoe on the end of the pipe where the slurry comes out, and that shoe is actually running through the grass, separating the grass and placing the slurry, I suppose, underneath the grass, just on top of the soil. So they're kind of the two slight differences between a trailing shoe and a dribble bar. And as a result, the contamination with a trailing shoe would be slightly less than what you'd have with a dribble bar. And what we have found on farms is that typically in springtime, we would recommend spreading slurry with a splash plate on paddocks where the cover of grass is very low to avoid contamination, and you would have to leave anywhere from 4 to 6 weeks before you can graze that paddock again. Whereas the interval between spreading slurry and grazing is greatly reduced when you use a trailing shoe and dribble bar. There's no actual full work done on this, but from what we've been hearing from farmers on the ground, some farmers are able to go in after spreading slurry anywhere from maybe 2 to 3 weeks once they've used the trailing shoe and dribble bar because of the reduced contamination of the grass. And another point, and it isn't something that's highlighted that often, but where I see there's a massive benefit with these techniques, is that in general, when we fill our tanker in the yard, in the springtime. Where we're going to go with that slurry is going to be the paddock with the lowest cover of grass, because we can't contaminate our grass for grazing. That same paddock with the lowest cover, it may be an index 4 for P and K, whereas there could be a paddock that is also close to the yard but is also an index 1 or 2 for P and K, but it has a high cover of grass on it. So we can't get our slurry there with our splash plate because we'll contaminate that grass. But what the trailing shoe and dribble bar is allowing us to do is it will allow us to go into those paddocks. Even though if there's a cover of grass up to 1,000 or 1,200 kgs of dry matter per hectare, we can still put the slurry in those paddocks and allow it. Again, it kind of goes back to where I was talking about where we should use our slurry to target it to the index 1 and 2. So these techniques are actually opening up the flexibility of where we can put our slurry. We can target our slurry to the paddocks that need them the most.
And just to pick up then on your point, there's more nutrients available with our dribble bar or our trail and shoe when we compare it with the splash plate. Are there figures for that yet, William?
Yeah, so the work that was done in Teagasc, Johnstown Castle, has found that when you spread slurry with your trailing shoe or dribble bar, typically you're getting an extra 3 units of nitrogen per 1,000 gallons spread. So I'll just give you an example of this. If you were spreading 3,000 gallons of slurry with a splash plate in the springtime, that will be the equivalent of 18 units per acre. Whereas if you were spreading 3,000 gallons to the acre with a dribble bar or trailing shoe, it would increase this up to about 27 units of nitrogen per acre. So another way that these techniques can be used is if you can apply your slurry in the springtime, that 27 units from the slurry could potentially be used to reduce or to eliminate that half bag of urea that's spread in the springtime. So that's an extra, I suppose, cost saving that can be used for farmers.
So you've listed a lot of benefits, I suppose, in terms of environmentally and to the farmer, they're reducing the greenhouse gas and ammonia emissions. In terms of, I suppose, direct farmer effects, we're reducing the amount of ground that may be contaminated. We're improving our nutrient availability on farms, and we're also increasing our flexibility in terms of where we can go with slurry in the springtime. When we look at the cost of these methods, is it more expensive to, say, hire a contractor with a dribble bar or trail and shoe compared with a standard splash plate slurry tank? Yeah,
so typically what we would find from talking to farmers and asking them about, what extra costs they're being charged by their contractors, it's anywhere from about 10 to 25 euros per hour more to get your slurry spread with a trailing shoe or dribble bar compared to the conventional splash plate. So look, it is an extra cost, but we can, if we break it down and look at the extra 3 units of nitrogen that you're gaining, and I've worked this out this morning as well, it's kind of showing that the extra nitrogen that's being made available, that can go a long way in even almost completely cover the cost of the extra cost of the contractor with this type of method. Some farmers then are going down the route of actually going and purchasing these machines, and typically, depending on the make and the model of the tank that you're buying, it's probably costing you anywhere between 13 to 15,000 euros more to buy a slurry tanker that has a trailing shoe or a dribble bar on it. But I'd also just like to point out on that, though, that there is TAMS grants available for these machines. So typically, farmers can get a 40% grant, so they get 40% of that 13 to 15,000, or the young trained farmer can get up to a 60% grant. So the grants can help, to take out I suppose that the worst of this extra capital cost.
And then just to turn our attention to, I suppose, chemical fertilizer. We've chatted previously about the idea of protected urea. Can you remind us again, what is the differentiation between protected urea and then the urea and can products that we would typically use?
So the protected urea, Emma-Louise, is the exact same urea granule that we've been spreading for years on our farm. But basically what the protected urea has is that there has been a coating, a slight coating put on the urea granule. And what's on that coating is an inhibitor. And this inhibitor is called, its trade name is called agritane. And what that is doing, Emma-Louise, is that it reduces the, I suppose, ammonia gas emissions that can be associated with urea. Like traditionally, farmers will spread urea in the springtime under kind of the more cooler, wetter, damper conditions where there's less evaporation. So what that protection is doing is that it can allow you to kind of continue using a urea-based product kind of for the summertime. So is what Teagasc has found. So Teagasc has done extensive work on this. It compared urea, can and protected urea in a grassland site here in Cork, down in Wexford, and actually up in Belfast for 2 years running. It measured things like grass growth, the total tons of grass that are grown on the 3 sites, and it measured greenhouse gas emissions and ammonia emissions from the 3 different fertilizers. And basically the main findings that it had was that the 3 fertilizers grew similar amounts of grass across the 3 different sites. And those sites were kind of typically one dry site, one average site, and then one kind of wetter or a more poorer draining site. And what they also found was that the protected urea and urea had the lowest greenhouse gas emissions, and the can and the protected urea had the lowest ammonia emissions. So I suppose to kind of sum up the work, and what I be always talking to about farmers is that the work has shown that protected urea grows the same amount of grass as can. Protected urea is slightly cheaper than can when we look at it on a per kilogram or per unit of nitrogen, when we work back to that. And also the main thing, another thing as well, is that the protected urea is ticking the box very muchly in terms of having, I suppose, the better environmental performance, which is important in terms of the context of those targets that I was talking to you about a bit earlier.
And I suppose that is going to probably become regulation. So we need to get comfortable, I suppose, with understanding what protected urea has to offer us and how we use it. I suppose finally then, William, ye have done some work in terms of a demonstration of the different types of slurry spreading in advance of the open day. Can you tell us about that? Yeah,
so here in Moore Park, what we have set up just to be able to show farmers on the day, we have spread slurry with a trailing shoe and a dribble bar, and we have them at kind of 3 different stages. So some of the ground was cut off and spread with a trailing shoe and dribble bar side by side a number of weeks ago. So you'll be able to see the difference in grass yield between those 2 techniques. And also we'll have a plot where the slurry will have recently been applied with both the splash plate and trailing shoe. So that'll allow people on the day to see the difference between the grass contamination as well. So look, I'd encourage people to, if they're there on the day, to come up. Myself and Patrick Forrestal from Johnstone Castle will be there, and we'll be really happy to answer any questions or to go through any queries that people have on the day.
Looking forward to seeing it. Thank you, William.
Thanks, Emma-Louise.
And that's it for this week's episode of the Dairy Edge podcast, and my thanks to William Burchill for joining me on this week's show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify, and for more information go to the Teagasc website at teagasc.ie. I'm Emma-Louise Coffey, and join me next time for your Dairy Edge.